All right, welcome to the notes for section 4-1. We're looking at solving various types of equations. So far this year, we've gone through and solved a variety of equations. We've looked at just general linear equations. We've talked about quadratic equations. We've worked on solving radical equations and rational equations. So today we're going to look at some of these and a couple others as we begin chapter 4. The first one we'll review here is solving a quadratic. This first one you'll see here we have the quantity of x plus 3 squared minus 5 equals 4. There are a couple ways to do this, but what we're going to do right now is work on undoing the equation to solve for x. So when we have these grouping symbols, like right now we have this grouping symbol here, the quantity of x plus 3 squared, and then the minus 5 equals 4, we're going to work on getting that grouping symbol by itself. So we're just going to do the inverse operation by getting rid of everything else on that side. So we're going to add 5 to each side. Now we have the quantity of x plus 3 squared is equal to 9. And to undo our square root here, we're going to actually, sorry about that, I'm going to just get my different pens up there. So we're going to take the square root of each side, and when we take the square root of something that is squared, remember we're going to end up with the absolute value of x plus 3, and then that should now equal 3. And we're going to take that absolute value because there's two values that we have that are 3 units from 0, right? We could have the absolute value of negative 3 equals 3 and the absolute value of positive 3 equals 3. So what we're going to do here is we're going to take out our x plus 3 and we are going to set it equal to a negative 3, and we're going to set that same value equal to positive 3. Because we know that whatever's inside those absolute value brackets has to end up equaling negative 3 or positive 3. Now we'll just finish solving it here. We'll take away our 3, and we've got x is equal to negative 6. And same thing on the other side, we'll get that x equals 0. Now we can take either one of these and plug them back in, and it should make a true statement there. I'll do an example on this one here. So negative 6 plus 3 is negative 3. And then when we square that, that's going to be 9. 9 minus 5 should equal 4. So you'll see that that is true. You should be able to do the same thing. You can try checking the 0 to make sure it is correct. All right, moving on to the next type of problem here that we've recently solved, and we're going to look at solving some rational equations here. Looking at 2a right now, we have the quantity of x minus 5 over 4 plus 2 over 5 equals 9 over 10. So our strategy here for solving this is we want to get rid of the fractions altogether. In order to do that, we need to multiply by a number that is divisible by each of our denominators, 4, 5, and 10. You could call it the least common denominator, but you can multiply by anything that is divisible by these numbers. So a number that each of these goes into is 20. So if I multiply both sides of the equation by 20, I can look to reduce here. I'd be saying 20 times the quantity of x minus 5 over 4 plus 20 times 2 over 5, and that should equal 20 times 9 over 10. Now you don't have to show this step each time here, but I'm just showing it here so that we understand that we can reduce these. 4 is a factor of 20, and that's why we multiplied by 20. So that would reduce to a 5. 5 is a factor of 20 and 5, so it becomes a 4 here. And then 10 is a factor of 20, so we'll reduce that there. That should become a 2. So what we're looking at here is 5 times the quantity of x minus 5 plus 4 times 2 equals 2 times 9. Now all we need to do is simplify and solve. So we're going to have a 5x minus 25 plus 8 equals 18. Negative 25 and 8 is going to give us a negative 17. So we're going to take this and add it to each side. And we now have 5x is equal to 35. And x ends up equaling 7. That value can be plugged back in and checked there. For time's sake, I'm going to tell you that it works. Same thing here with problem 2b. We have 5 over x plus 1 over 3x equals 4x over 3. Our least common denominator here, our least common denominator is going to end up being something that is divisible by each of those denominators. So that would end up being here for this one, 3x. Let's multiply each side by 3x. We're going to distribute this to each part of it. So we're saying 3x times 5, and then we're going to divide it by x. So our x's will end up canceling here, and we should end up with 15. So I'm cutting out this step that you saw over here in the previous problem here. We've done enough of these that hopefully we can, be a little bit more efficient and do the simplifying and canceling as we go. If I do 3x times 1, it's 3x, and I divide it by 3x there. That's going to leave me with just 1. So 15 plus 1 is going to equal, on this side, 3x times 4x is 12x squared, but then we're going to divide by the 3, which is going to make it back into 4x squared. Now we'll simplify the left side. We have 16. That equals 4x squared. And since we only have a single x term here, and it's the one that's squared, we can go ahead here and isolate it. So we'll divide each side by 4. 4 equals x squared. We'll take the square root of each side. Once again, we have to remember the square root of something squared there is going to give us that absolute value of x. That should equal 2, which means that x should end up equaling positive or negative 2. We can take those values, plug them in to double check and make sure they work. With this one, we also need to check out our excluded values. Our excluded values for this one, remember, that's any value that would make the denominator equal 0. In this case, the only thing that x should not be able to equal is 0. But since we got positive and negative 2, we're okay there. All right, moving along to the next problem, we're going to review the equations with square roots. The most important thing here is we want to isolate the square root before we square each side. Now we just did these in the last chapter, so hopefully it's still fresh. To isolate the square root, I'm talking about the square root of 4x minus 8, we need to get rid of what's not attached to it first. We're going to subtract the 9 from each side. That would give us 6 equals 3 times the square root of 4x minus 8. Next, we're going to divide by the 3. We now have 4x minus 8 left inside the square root, and that should equal 2. So the square root of some value should equal 2. Well, we know the square root of 4 ends up equaling 2, but we can illustrate this by squaring both sides to get rid of the square root. We now have 4x minus 8 equals 4. We're going to add 8 to each side. So 4x equals 12. And we'll get that x equals 3. Again, this is with the square roots. It's always important to make sure you're double checking. We'll check this one. We haven't checked them all, but these are notes, and I'm trying not to feed you bad information here. So we'll check it here. I'd like to set a good example for you. If we take our 3 and we plug it in, we have 3 times the square root of 4 times 3 minus 8. And then when we add 9 to that, it should end up equaling 15. Well, 4 times 3 is 12, and 12 minus 8 is 4. So right now we have 3 times the square root of 4 plus 9. which is 3 times 2 plus 9. So 6 plus 9 should equal 15. So 15 equals 15. All right. So that is the end of page 1 of the notes. I'm going to include the second part of the notes on a second video. If you have questions, please make sure you mark them down and bring them to class with you. Then go ahead and click on the second video for the last part.